Hello friends! The only thing I would like to mention regarding this review is that lots of users, including my subscribers, were waiting for this video. Moreover, I also dreamed to get two-channel oscilloscope with XY mode, which is portable and at the same time has signal generator. You can also watch two reviews on my channel dedicated to Hantek 2D42 and Jinhan JDS2023. But the first channel of Jinhan oscilloscope is analog and the second one is digital. Moreover, there is no XY mode. As to Hantek device, both channels are analog. Moreover, it has multimeter functions and of course the device is portable, but still there is no XY mode. And if you would like to get this mode, you can get the oscilloscope Jinhan JDS2022A. That device is a bit more expensive, but it has no signal generator. But last year I've revealed a very interesting device, which is single-channel oscilloscope and a signal generator at the same time, which is not expensive at all, but has some interesting functions. For example, you can check the waveform of the mains voltage without any additional device, and also it has FFT function. I mean Fourier fast transform, and sometimes it's very useful. But in this video we will discuss two-channel oscilloscope with XY mode, with a signal generator which can generate different waveforms and which is also portable and not expensive. The device comes in a small bag, includes the manual, USB cable for charging and file transfer, it has Type-C connection, two probes, a screwdriver, two alligator probes for the signal generator, the manual for the probes, and one more accessory which will be shown a bit later. Dimensions: 13.5 centimeters, 8.5 centimeters, 3.5 centimeters. As to the weight, it amounts to 285 grams. Here we have channel 1, channel 2, here nothing, here nothing, here also nothing, and here Type-C port for charging and file transfer. Here we have LED, which is red during charging and green if the device is fully charged. The sockets for the signal generator plugs, and I'll explain the destination of this socket a bit later. Let's turn this device on. SigPeak. I would like to note that it's very easy to work with this device. Moreover, the manufacturer has made some changes and it's easier to use this two-channel oscilloscope in comparison with its single-channel brother. Here we have power button, which is multifunction, or let's say shift button at the same time. Save, we can save the graphs for subsequent transferring to the PC. We can switch the channels and even switch the second channel off. This is the signal generator button. Seconds, nanoseconds, horizontal sensitivity. Volts, millivolts, vertical sensitivity. Auto is auto adjustment. Menu is menu. Run stop is used both for the oscilloscope and the signal generator, and also here we have single button for single measurement. Let's check the menu. Coupling, DC-AC first channel, second channel, probe 1x, 10x, 100x, also for the second channel. The next, measurement. We can select the parameter we want to display. Don't want. Don't want. We want all. So all the parameters. Don't want. Only frequency and peak to peak. Trigger mode auto, trigger type rise, trigger level auto, and a very important switch, source channel 1, channel 2. channel 2. In case of channel 1, this arrow becomes yellow for the channel 1, 1. In case of channel 2, it becomes green. Display. Everything is the same as in the signal channel oscilloscope except this line. Mode. YT or XY, and it's excellent. YT. Then calibration. Remove the probe first, please. FFT off. Log. Linear. Music. And we can see the changes. Now we have no signal. And finally, set. Auto shutdown, sounds, and the menu, Chinese and English. As to the signal generator, we should use these two alligator probes. And the first channel is yellow. So, this one. F1. Frequency, hertz, kilohertz, megahertz, duty cycle, and the waveform. 25 hertz. 25 hertz. Run. Auto. It's too low frequency for this device. But at the same time, here we have green arrow, and it means that the device is oriented to the second channel. Menu. Trigger second channel. The first channel. And the graph stops. Once again, auto. Now it's okay. I really was afraid of problems with this device, but it's really okay. Signal generator, 30 kilohertz. Then kilohertz, and then square waveform. How to change it? V and MV. Other waveforms. A very interesting waveform. Also, as to the frequency limit, square waveform, let it be 30 megahertz, which is not possible. So the maximum is 2 megahertz. Also 2 megahertz, 2 megahertz, 2 megahertz, 2 megahertz, also, And as for the sinusoidal signal, here we have up to 10 MHz. The frequency 10 MHz. It's dancing a bit, but anyway it's okay. Let's check the second channel with the same signal generator. We can move the yellow graph because here we have channel 1, yellow. But in case of the second channel, we press channel 1, channel 2, and here we have green. Let's make it a bit lower. Now it's okay. Frequencies are the same, but here the voltage is 10 times higher. Menu. Now everything is the same. But let's check this device with the second signal generator, and it will be really interesting. So here we have the second channel. And let's adjust this device to 1 MHz signal. As to the XY mode, the Lissajou figures. So if you know the advantage of this mode, you will really appreciate the device. And now about some changes made by the manufacturer after production of single-channel oscilloscope. If you would like to use XY mode, there is no need to go to the menu and move to display. Power button OK. And also power button OK. Also, for AC-DC coupling, there is no need to go to the menu and then to this channel 1. For the channel 1, power auto, DC, AC. For the channel 2, power run stop, DC, AC. As to the probe attenuation, first channel, power menu, 10x, 100x, 1x. Of the second channel, power single, 10x, 100x, 1x. Also we have cursor function, power S, vertical, also we can adjust it, power NS, horizontal one, both cursors, horizontal and vertical, trigger rising or falling edge, power safe, fall, rise. In order to switch trigger source, also there is no need to go to the menu, then here. We simply press power and channel 1, channel 2. Here the arrow is green and now it's yellow. In case we use up and down arrows, we move the priority channel graph. But if you would like also to move this low priority channel graph, power, also, in order to obtain a higher sampling rate and reduce the power consumption, it's better to turn the second channel off. Long press. And we have only one channel. How to save the graph? Simply save. Save done. How to see such graphs? Long press. You can also delete one of them. Stop. And it's deleted. Let's delete also this one. And how to see them on the PC? You use this USB cable, go to the menu, then set, and then long press NS. USB connect. You just transfer the files and then turn the device off. As to FFT mode more precisely, here we can see the peak, linear. Now it's here. And as to music mode, let's change the waveform. So this FFT mode can be also used for sound monitoring. And now about the advantage of this device, which was mentioned but was not explained. So one more accessory which comes with this device is AV cable. And this is one more useful function for such portable device, which can be used also during conferences, lessons, etc. Video to video. SigPeak. And what should we do now? We go to the menu, set, and then a long press run stop. In case of portable devices, they may say that the only disadvantage is a small screen. But in this situation, this device has almost no disadvantages, as exactly this issue is solved easily. So you can use small displays, even as well as large walls. Also, let's see some display functions. One second. So sometimes it's useful. Infinity. Now let's disassemble the device. Here we have absolutely no inscription, but the battery is very large. As to the board, here we can see the relays of both channels and even the slot for the memory card. Most likely the manufacturer plans to increase the internal memory of this device in order to store more graphs for their subsequent transfer to PC. Here we can see the inscription version 8.7. Previous versions had no AV output and their menu was only in Chinese. And moreover, 2 months ago, the manufacturer refused to send me a device without video output. So the company decided to improve it, and the current one can be used together with any monitor with AV input. As to my opinion, I'm completely satisfied with this oscilloscope. And speaking about the comparison of Hantek 2D42 and SigPeak DSO2512G, I really don't regret that SigPeak has no multimeter, as the maximum you can use together with the oscilloscope is more or less decent signal generator. And exactly this device does have it. I also would like to mention that I've tested Hantek's multimeter, and it has a really good accuracy, especially for 3-in-1 device. But as for me, I have no need of 3-in-1 device, and 2-channel oscilloscope, including the signal generator, satisfies me completely. As to checking of the mains voltage waveform, extended attenuation of this probe is sufficient for it. Well, this part of sinusoid is flat exactly because of the mains voltage. And now a pair of words about XY mode. Lots of users on YouTube speak about the necessity of this mode and its importance, but let's discuss this issue in details. Besides, we can see 2 signals with the help of this oscilloscope, and also we can see the difference between them. We can also check the components exactly with the help of XY mode. Here is the scheme. So here is the transformer. We have no need of the rectifier. The first wire goes to the X probe. The second wire goes to Y probe. Green, green. And also we have 3 kΩ resistor between X probe and ground. Here is the resistor. This is ground. Also this is ground wire. And the component which we would like to test should be connected here, between Y and ground. This is ground and this is Y. As to the power source, here we have 12-volt output. Let's turn the transformer on. Naturally, here we have sinusoidal signal and the channel is number 2. So we have sinusoidal between GND and Y. And what about XY mode? Let's explain what it means. In YT mode, here we have voltage, and here time. But in XY mode we have no T. And if in this mode the signal goes this way, then in XY mode without T we have only voltage axis, the graph will be as narrow as possible. So instead of this one, we will have only this one here. So in XY mode we have the following: up, down, up, down, up, down. And now why this line is vertical and not horizontal? Because we have channel 2. In case of channel 1 and in case of absence of the signal on channel 2, we would have the horizontal line. Now let's check some components with the help of XY mode. The resistor. The resistance is 2 kilo ohms. So the angle is changed, and it means that the resistor is okay. But let's check what happens in YT mode. So the signal on Y channel changes, and also we can see the phase shift. Once again, XY mode. Now the resistor is on, and here without the resistor, and now with the resistor. XY mode. Capacitor 2.2 microfarads. A very interesting picture. And the question is, why exactly a circle? It's a bit difficult to understand here because we have a signal in X direction, in Y direction, and even in all the directions. But let's see both signals in the common mode of the oscilloscope. Here we have 2 sinusoids. Also we can see the phase shift, and if the signal of the first channel amounts to 0, we have these 2 points, and if the signal of the second channel amounts to 0, we have these 2 points. Another capacitor, 500 nanofarads. Also a circle. It works. Also the capacitor, 220 microfarads. A line. Why? Is it faulty or not? Let's check YT mode. We can see something here on the second channel, but the signal is too weak. Let's press Auto button. So everything is okay, simply the capacity is too large. And now as to YT mode, let's check a diode. S9340. L. Is it possible to adjust the graph? Yes, it's possible. What can we say in view of this graph? In case of positive voltage on the first channel, we have no voltage on the second channel, and vice versa. In case of positive voltage on the second channel, we have no voltage on the first channel. So here we can see a visual specification of a diode. But let's see what happens in YT mode. If we have positive voltage on the first channel, we have 0 voltage on the second channel. And in case we have positive voltage on the second channel, we have 0 voltage on the first channel. Let's reverse the polarity. And we have the same letter L. Let's adjust it. and YT mode again. So here is excellent visual explanation of the situation. Let's investigate this component. We have either diodes or transistors inside. Unfortunately, I have no Zener diodes, but the part of the scheme inside of this component behaves like a Zener diode. Let's see the YT mode. A very interesting graph. In case of zero signal on the second channel, here we have negative signal. In case of the positive signal of the first channel, here we have almost negative signal. But let's switch the oscilloscope to the first channel and move it. So here we have no sinusoidal but almost sinusoidal signal. And that's why here we have not L but Z. Very interesting. And finally, a triac BT136. Here we have a line, but it's almost a line. Let's check YT mode. The graph is dancing because of this green line. It means that the oscilloscope is synchronized by the second channel. Let's switch it. Power channel 1. And we see that the signal on the second channel is really too weak. XY mode. Auto. Really a very interesting graph. I must say, a very interesting Z. Let's try to understand it with the help of YT mode. This graph is more interesting than the previous one. In case of positive sinusoid on the first channel, we have negative signal of almost square waveform on the second channel. And vice versa. Second channel, positive square waveform. The first channel, negative sinusoid. Once again, XY mode. And also we can move it. So this device will necessarily help you in testing of different components. And finally, about the conclusions. Hope everything was mentioned in this review regarding this device. But anyway, the only disadvantage I have found is that the device has no reference waveform, so we cannot save the waveform and compare it with the current one. But in case of presence of so many advantages, I can't say anything about disadvantages of this oscilloscope. As to the advantages, the device has two channels, both are analog, screen size is 2.8 inches. According to the manufacturer, the bandwidth of this device amounts to 120 MHz and the sampling rate amounts to 500 megasamples. The minimum of the horizontal sensitivity amounts to 5 nanoseconds and the maximum 10 seconds. As to the vertical sensitivity, the minimum is 10 millivolts and the maximum is 10 volts per division. Naturally, the device has AC and DC coupling. The oscilloscope supports XY mode, can save screenshots, transfer them to your PC. Besides, the oscilloscope supports fast Fourier transform function. As to the signal generator, the waveform amplitude amounts to 2.5 volts and it can generate different waveforms with a frequency up to 2 MHz. As to the sine waveform, it can be generated up to 10 MHz. So regarding this two-in-one device, I have only positive opinion and I cannot find even small disadvantage of it. Thus, in case 120 MHz is sufficient for you and you would like to get two-channel oscilloscope with the signal generator, which is capable to generate different waveforms, this device is definitely for you. Thanks for watching. Wish you good luck.